Hi, welcome to this second tutorial in which we will run some simulations that tries to mimic the behavior of paper or poplar. For that we will use kangaroo physics that you find in Grasshopper. How it works, this plugin is that we set some points, some particles in the simulations, and we set up also some interactions between all these points with all these goals here. And then you have a main solver that will try to answer to all of these goals. So let's see how it works with a simple line first. So you can set one line in Rhino. Yes, and we will say that the start of this line stay in positions, so we will anchor it. So this goal says, okay, this point, we will try to keep it in place. And then another goal is length line. And this time it will take the two ends of the line and try to keep it with the same distance as at the beginning. And then in order to interact with it, we will use a grab component. And we also add it in the solver. So the simulation is converged at the moment because the length is already the good one. But if we try to interact with it with the keyboard Alt, we can move the point which is not anchored. And you can see that you cannot make the line too long. In fact, you stretch it, and you also cannot make it too short. In fact, it is not short here. If you go in 3D, it is just in a different direction, but it still has the same length. Just be careful of one thing, is that it is not because you ask this line to stay with the same length that it will necessarily have the same length. For example, here if we stretch it with a more stronger force on the right, then the length of the line will be slightly longer. Okay, let's see how we can make this work on a piece of paper now. So we can set one rectangle. Oops, in Rhino. And we will import it in Grasshopper. And now we will just make with boundary surface a surface. And now in order to get some points on it and make interactions, we need to make a mesh out of it. We just use the one from Karamba, and the mesh resolution, you can check if it's good with mesh edges and try to get it. Yes. You can also make it more equal length. And then we can set some goals on this mesh. So the first thing that we want to set up is that the edges of the mesh stay with the same length. So edge length. We give it a very strong strength so that it will be less elastic. It will have more strength to stay with the same length. And now we also set some hinge and some hinge points that you find here, and it will just take sorry, I just display again the mesh edges. It will take each pair of triangles, for example these two ones, and along this axis in between them it will try that this point and this point stay in the flat plane. So indeed it will in the end it will try that it stays flat, so it does not bend too much. We have a strength of 20, I think is good. And finally we take back the grab component and we make a solver. last thing we will do also is to show the mesh in the simulation. And let's reset. Yes, perfect. And see if we can interact with it. So with Alt on the keyboard, you can see that you have a piece of, say, wood maybe, that tries to not bend too much and tries to stay flat. Okay, I will just show you something that you can, I think, download from the downloadable part of the workshop, and which is basically the same thing that the hinge, but which I slightly modified so that we will see in a second. Yes, so that in fact, when you start to bend it, it will be able to bend quite a lot in the direction of the bending, but it will bend much less in the other direction, which is a bit more like paper works, because, or Poplar, because when you start to bend some surface, then it will be much less easier to bend it in the other direction, and so this corresponds much more to the behavior of paper. Okay, let's try to do something more fancy with this piece of paper, and let's try to cut one part of it and to connect these two parts together so that we can make something that rises in a space surface. We just redo this surface with this like that, and okay, and now we want to say, wait, I will just stop the simulation for now. And we will say that we want this to be glued with this. So we just add one line here and one line here, and we take them in Grasshopper. Okay, now we divide them with a certain length between each point. That would be around, you know, something that fits to the scale. And the other one, we also divide it with the same length, and now we just make sure that we have the same amount of points in each list. So we take the shortest one and we trim the other one. And now we want to include this point in the initial mesh. So we take them and we say, here we want to include the point. And finally, we will set up a new goal, which you find in goal point here, coincident, and we say, okay, these points will coincide with these points, so they will try to be glued together. We place it in the solver, and let's run the simulation. Okay, it's kind of stuck in the plane, but we can help it to go in more 3D. And you see how this gives a surface which rays in a space surface, as you could do it with paper. Okay, so this is a tool that you can use to start from a flat piece of paper and then to do some actions on it to give it some spatial characteristics. And there is also another way that you could use kangaroo physics, which is you start with a target shape, which is itself in 3D, and which is not developable. And then you start to try to patch it with developable parts. And you could do it with developable eyes, which is already implemented in Kangaroo. We will not do it now, but you can, if you want, get further on it. And there is a very nice paper which is based on that you can find in the workshop downloadable part. And yes, I recommend that you have a look on it. Okay, I think we will keep it like that for the kangaroo physics, but of course you can imagine how you could get further, and we can see this during the week. Alright, ciao!